Good morning, friends. We are learning our subject, that is data mining, right? So let us revise the last lecture contains, and then we'll start with the new contents. Fine. So let's see that what we have learned in last lecture, data mining definition. So recall that data mining is the process of extracting interesting, non trivial, implicit, previously unknown, and potentially useful patterns or knowledge from huge amount of data. We have talked of, we are having the descriptive and predictive models. So what they contain? Predictive model contains, or it includes, the classification, regression, time series analysis, and prediction. The descriptive tasks are used to find out patterns in data, that is, clustering, summarization, association rules, correlation, trends and anomalies, and sequence discovery, and many more things, right? So we want to know about all these things, and that's what is we are going to study today. So data mining functionalities, and in that now we want to study, that is classification. What is that? Classification is used to build models from data with predefined classes, as the model is used to classify new instance whose classification is not known. So what actually we want to do? For example, we have, say, animal data set. For example, we have animal data set. So over there, we do have the idea, that is, we can say we are having our cat, dog. We can say we are having cat and dog, right? These are the classes available. What do you mean by classes? That is, you can say categories. The data which we are having, animal data set, in that we have cat and dog. So what to do? Based on the data, that is, you can say pictures. Pictures of, say, our cat and dog, we will train the model the way we used to learn it in our childhood, that we will be having cat and dog. Let me put it here, so that will make your life simple. In the way, let me show you it here. Okay, so you can understand that well. Text, if you are able to see, you can understand it well. Fine. So let us say that we are having the data wherein we do have the data set of cat, dog, right? Cats, many cats are there. So category wise, you can say cat, dog, and say other animals. So here we can say three classes are there. And if we consider only two, then we should not consider other, right? So what does this mean? That whatever data set we are having, in that we do have cat or dog, right? And if it is not known, or you can say if we are not able to put it in the cat category, if we are not able to put it in the dog category, then it is said as unknown animal, isn't it? So this is the class given, right? The label, you can say class or label is given in the data. That is for, say, picture is of cat. Let me show you that. If we are having the picture of cat, then we can understand that it is cat only, isn't it? This is cat. We can understand that. This we know, right? If it is having front face or if it is having, say, side face. If the eyes are open or eyes are closed, we can understand that it is cat only. Can we say so? Yes, of course. So what is given? That is, say, these two images and many more are there. For that, it is given that this is a photo of cat. This is a photo of cat. And for dog also, we are having something. That is, you can say some images are there. So let me put it here. Say for dog, here it is given. So for these photos, we do have the label given, the class given, and that is the cat. And here you can say it is given that this is dog, right? It is already given in the data. The label is already given to you. Say, you can say if the front face is there, or you can say side face is there, but still we recognize that it is dog, right? This we can understand. So now what is here? This is the training data wherein the class labels are already given, and what we want to do is, if any new image comes to you, let me say that this image comes to you, then you should be able to say that it is cat or dog. Obviously, it is dog. So, how did you recognize that? How did you recognize that? It is because you are having the features in your mind that dog means this type of shape, this type of color. You can say whatever data is there, the color is, this is similar to white and this is similar to, say, brown. So what unknown data is given to you, for that can you say it is dog only if I have considered the color? No, we cannot. From the features, that is, the shape of dog is something like this, his nose is something like this. From that only we can say that this is a photo of dog, right? So, what do we say? That is the classification. That means the classification is used to build models from the data with predefined classes. I have given you the example wherein we are having the predefined classes. They are the cat and dog. Fine. And based on that, we have built the model which is used to classify the new instance whose classification is not known for this particular photo. That is the dog, but that photo was not there in the training. Now, when we are giving this, it should be able to classify that this is a dog, right? So, the instances are used to create the model are known as training data. A decision tree or a set of classification rules is based on such type of mechanism of classification which can be retrieved for identification of future data, right? For example, one may classify the employee's potential salary based on the salary classification of similar employees in company. Right, one more example. There you can say, for example, For that, we can say if a person is, say, assistant professor. If a person is assistant professor, then you can say what is the salary of that person according to, say, university rules. If it is, say, 40K, then that will apply to all the people of the same category. Getting it? Right. So that is one more example for classification, right? From the known data, we build the model. From the known data, that is, whatever are the data of a particular person, assistant professors, that is, they are having, say, master degree, they are having, say, master in engineering, that is the, you can say, any branch, say mechanical, electrical, computer, electronics, right? Something like this, they are having this study qualification, and if they are getting permanent into engineering college, we can say them as assistant professor. And what will be the salary? We can definitely say that it is the base salary, that is 40K. Fine, something like that. That is the first salary which they are getting. For example, right? This is not the true digit. I have only said as example. Fine. Okay. So now we want to know about the next functionality, that is clustering. What is that? Clustering is the process of partitioning a set of object or data in a same group called cluster. These objects are more similar in some sense or other to each other than those in other groups. Clustering is used in many fields, including machine learning, pattern recognition, you can say bioinformatics, image analysis, and information retrieval. Right? So, let us take the example. We can have the idea. Now, here, let me say that the labels are not given. In the case of classification, the photos are there. And you can say the photos are given the label. That is photos or any other type of data, maybe text data, but the labels are given. That is, this is a cat, this is a dog, right? That label is there, and that is called the classification. Here in clustering, do we have the labels? No, we do not have the labels. In clustering, we do not have labels. Fine. Or you can say classes. They are not given to us. So, how do you group them? How do you group them? Let me tell you. Say in first year when you come to the college, how do you build your group? You see, this person is similar to me. This person is having hobbies like me. This person is coming nearer to my area. This person is having same as that of mine, right? So based on, say, your aim, your area, or you can say your characteristic in general, right? Your characteristics. So based on that, what you do is you are making the group, isn't it? The same thing, the same concept is being used, that is in the clustering, right? That the labels are not given. Labels are not given, right? It is not there. Still, you make the group based on your characteristics. She's having same aim like me. She's having same hobbies like me. She is coming from the area where I stay or nearby that, right? Something like that. These are the characteristics you try to find among your friends, your classmates, and then you make the group, right? So that is what is clustering. That is based on the characteristics of the data, whatever you consider for those particular objects, you try to combine them in a group. Objects which are there in the same group are having similar characteristics, and which are there in other group, they are having the dissimilar, or you can say different characteristics, right? Now for this subject, that is our data mining, you can study the data mining subject in NPTEL course, right? If you have studied this before, or if you think that this subject we are going to study here, then you can study the machine learning subject, right? So you can do register for NPTEL courses, because they are going to start from almost January 21, right? So start registering for them. Let us know about the more characteristics of functionalities, right? Data mining functionalities. So what is next? Mining frequent patterns, associations, and correlations. What is that? Let's see. Frequent patterns can be defined as a pattern, a set of items, subsequences, substructures, etc., that appears intermittently in the data. What do we mean to say? For example, say intermittent item set is a set of data that occurs frequently together. In a transaction data set, for example, a set of items such as table and chair. Subsequence means, first of all, buying a computer system, then UPS, and then after say printer. This appears frequently in a shopping history database and is called a frequent sequential pattern. Let me show you the example. Let me put it here so you can have the idea, right? So for that, let us say that you are visiting a mall, right? And there you have purchased the items, and that I am saying as transaction T1. In that, I have purchased bread, then butter, then say kurkure, then wafers. Right? I have purchased those things. Other person, say from your class, that person has purchased bread, butter, you can say biscuits, right? Other person, say T3 transaction. That person has purchased bread, butter, cheese, right? Now say fourth person. For that, T4 transaction is there. That person has purchased, say, biscuits. You can say wafers. Say kurkure, right? So what are the items we are considering here? Bread, butter, kurkure, wafers, and cheese, right? So this is what is considered, and that is called our item set. So in that we can write it as bread, butter, kurkure, wafers, and then after we can say biscuit, right? So typically we used to say it as our universal set, right? So that's what we are putting here. This is our full items set, right? Yeah, and the cheese. Okay. Yeah, I can write this example before also, but if we are writing like this, you can understand it better, right? Otherwise, I can write the example and put it here. Fine. So let us try to understand that this is the item set, or you can say universe of the items. Now, from that, person 1 has purchased the items that is there in T1 transaction. For second person, T2, T3, T4, right? So, for 4 persons, we have considered the transactions. Now, in that, you can see we can find the count of items which are appearing here in the transaction. For example, bread, how many times it is available? 1, 2, 3, right? So I can say bread is found 3 times. If I say butter, how many times it is available? It is available also 3 times, right? We can count it. It is very easy, isn't it? We can say this is 1, 2, and 3. Fine. So now if I want to consider, say, cheese, you can say for that, how many times it is found? Only once in this transaction, right? If I try to find, say, kurkure, how many times it is being found? 1 and 2, right? So that way we have to find the count. And we can say wafers, so how many times it is being found? 1 and 2, right? So we were having 1, 2, 3, 4, 5, 6. So you can say this is available 2 times, and one more which is available, that is biscuits, right? Let us put it here. So according to sorting of the words, we can say we can have that, right? So for biscuits, we can say it is found 2 times. One is here and second is here. Fine. So this is available 2 times. Now we can say this is the count of items which is available in our transactions. Fine. So, which one is available more times? We can say bread and butter. Yes. Okay. So this is the most frequent item. That is, bread is most frequent item. Butter is also most frequent item. So biscuit also should I consider the frequent item? Yes or no? For that, whether it is frequent or not, we are having the minimum count. Minimum count should be, say, 3. Then only it is considered as frequent item. Whether it is most frequent or not, it should be frequent, right? So for that, we should have some threshold value, that is the minimum count. So we can say that minimum count is, say, for example, it is 2. Then which items are frequent? Bread, butter, biscuits, kurkure, and wafers, right? If it is changed, and in the problem statement, if it is given as 1, then you can say all the items in these transactions are frequent, right? I'm not talking of whether it is most frequent or less frequent, right? We are only talking of that whether it is frequent or not, right? Whether it is frequent or not. So we can say that if it is crossing the minimum threshold, that is the minimum count, we can say it as the frequent item, right? So now if I want to find for 2 items, then what should I do? Say we are having the pair of bread and butter. Then can we say that bread and butter available once, twice, thrice? So you can say the combination, that is the items which are appearing together, for them we can say that bread and butter, they are the frequent items, right? They are available together. So let me write here bread and butter, right? So they are available thrice, but not separately. They are available thrice together, right? They are available thrice together. You can see that here. Bread and butter together, bread and butter together. Sequence doesn't matter in case if it is not here and if it is here at the end, it doesn't matter, right? It doesn't matter. But, or you can say if the butter comes first and then bread, it's okay. It doesn't matter. Their sequence, their order doesn't matter, but they are appearing together. So if I say that I want to consider the two items together, that is bread and butter, what is the count of it? They are appearing three times in the available transactions, right? And whether it is crossing the minimum count or not, yes, because we have considered the minimum count as 1. If it is say 2, then also it is crossing. So bread and butter pair also is frequent, right? If we are having say bread and biscuits, let us consider bread and biscuits. So for that, bread, and here no biscuits are there. Bread and biscuits, one time available. Here no biscuits are there. Here biscuits are there, but bread is not there. So what is the count of that? Together, they are available as a bread and biscuits. They are available only once. So is it crossing the minimum count? This count is typically said as minimum support count. We'll see that in detail, but minimum count, whatever is given in the problem statement, here is it crossing? No, because it is 1 and minimum count is 2. So this pair is not frequent, right? So I hope it is clear to you that the items, that is singular items, or pair, maybe say two items, then after we may consider three items, four items, five items, maximum whatever are there in the item set, right? That is a universe of items. In that, whatever number of items are there, that pair, that is those many items, if are considered together, are they crossing the minimum count or not? If it is crossing, then it is said as the frequent item, right? Frequent item, right? Okay. And if it is not crossing that, it is not called frequent item, or we can say it as infrequent item, right? Actually, there is no word infrequent or unfrequent for us in our technical subject. We only consider, we do have importance of only frequent patterns, that is frequent items, as whether they are of single items or two items or three items or four, whatever, but we do have importance for frequent patterns, right? So take care of that. And here also we have considered the same example, right? That is for computer system. Say people are purchasing computer system, UPS, and hand printer. If this pattern, this subsequence is found many times in the transactions, and many times means what? In all the transactions? No. Whatever is the minimum count given, if it is crossing that, then that subsequence pattern is said as frequent. Fine. So discovering such type of frequent pattern plays an important role in correlation mining, association, clustering, and other data mining tasks. We can correlate that those items, right? We can correlate. Okay, people are purchasing bread, they will purchase butter also, they will purchase cheese also, something like that, right? Or you can say they will purchase sauce also because they want to make the sandwich, right? So something like that we can consider. So next functionality which we want to know is outlier analysis. What is that? Outlier analysis is an object in database which is significantly different from other data. That is the existing data. What do we mean by that? Hmm. Let me say you. If, say, you people are there in the college, that is known to you that you are CKPCET students. And if a person comes from X college, we can say that person is outlier for our system because that person is not CKPCET student, right? So that person is outlier. Let us say that, see, in our school days, we used to write like select a thing which is not in this particular group. Like we used to say it as say pen, pencil, rubber, right? If I have written pen, pencil, rubber, and say wafer. What is outlier? Which is not part of this group. Obviously, we can say it is wafer. Yes or no? Yes, isn't it? Because that is not part of the group which we are considering here. Pen, pencil, and rubber, they are the writing or you can say drawing objects. But wafer is not part of this particular group, right? So it is different from the general behavior of the existing system. And that is why this is said as outlier, right? In schools, we used to do something like this, that whichever is not matching, keep it aside or round it or tick mark it, right? So these things are the outliers. But here, what do we say is different items are there. Now, in our systems, we may be having the same systems, same objects, I mean, similar type of objects, but wherein we should try to find which objects are having different characteristics. It may be something like this, it may be the data of the same object, but where some normal things are not there. Let me say you the example. For example, say I have the habit of calling Indian people only. For example, if you say that, or if you see my call history, you can say that I am having the habit of calling Indian people only. And if suddenly you will find that I am calling, say, other country, or you can say foreign country people, then what you will think? This is outlier, right? So telephone companies will think till now this person was having the history wherein this person was calling only Indian people. Now suddenly this person has started calling foreign people. So something is different, right? So that is being captured, or you can say that is a different characteristic. Maybe that fraud can be that is my phone is being hacked by some other people and they are using it to call the foreign country people. Or you can say it may be normal that I am working with say foreign people for research, and that's why I have started it. but 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 that is having the different characteristic, different behavior, you can say, suddenly found in the data, and that is what is called as the outlier, right? We can say, if my normal trend, that is, suppose, say every month I am withdrawing 10k rupees from my account, for example. Okay. So that is a normal behavior. 10, then you can say 12. Okay. Some limit you can set, some threshold you can set, but you can say 10, 15, 10 to 20 is okay. But if suddenly I start withdrawing, say, 1 lakh, then people will be surprised. Oh, what happened? From where this person is having the money? Isn't it? That is what is outlier. And that is being useful for detecting the fraud, right? That is what is being used in detecting the fraud. Okay, so now you understand. Outlier analysis is an object in database which is significantly different from the existing data. An outlier is an observation which deviates so much from the other observations as to arouse suspicious that it was generated by a different mechanism, right? And there you can say the deviance, sorry, abnormalities, discordant, and anomalies are also referred to as outliers in data mining and statistics literature, right? So the outlier can be diagnosed with the help of statistical tests that assume probability model for the data. So next is what we want to learn is generalization. What is there? Information integration and data warehouse construction. Say first of all, what is data warehouse? Typically, what we say as the warehouse. Warehouse is the dump, isn't it? We can typically say that it is a dump, right? Let me say warehouse is a dump where you can say all types of data are there, isn't it? When we say it as the cloth warehouse, there different types of clothes are dumped. And here we can say data warehouse. So we are considering it as the dump of different types of data. Different means different structured data can be there, structured or unstructured data can be there, right? So we are talking of the generalization, but wherein we can say that information integration is there. Say from database 1, say MySQL is there, second one is say Oracle is there, say third one is flat files are there. We are integrating them to have the data warehouse, right? You can say, why should we do that? We want to have the data mining. For that, we should be having the history of data, and that is only from one form we want to have. No, we can be having it from many other forms, right? So we can say that we are integrating the data, right? That is from, we are integrating the information, but what we are making out of it? We are making the data warehouse, right? Okay, so where the structured, unstructured, many types of data is there. The form is maybe image, a text, video, many things can be there, right? Okay, so what happens when we are integrating at that time? Say You can consider that simple results are there, right? So say college A has given the grades, that is in the form of A, B, and C, right? Now, a B college, they have given the grades, that is in the form of, say, 1, 2, 3 class, right? Somebody may have given it as X, Y, Z. Now, how to integrate this? Can we have any relation between them? From seeing only these grades, we cannot understand. But say marks distributions are there, say A grade, then it is, you can say 9 or 10 out of 10 is there. For B, you can say 8 and 7. And for C, you can say it is 6. If it is something like this, we can integrate that, right? Similarly, say here it is given as this is 9, this is, you can say 8 and 7. Then, then after we can say, not here, it is after this two, right? Okay. And for 3, it is a 6. If it is given something like this, we can integrate that. Same thing is there for XYZ, right? If it is so, then we can say we will be able to integrate it as the 1. 1 means wherever the A, B, C grades are there, wherever the 1, 2, 3 grades are there, and wherever XYZ grades are there, we can integrate it in a such a way that we'll be having the data in the same form. That means, suppose we are giving it as A, B, C only. So for whole data, whether it is from A college, B college, or we can say C college, we do have the data wherein we are having the grades. They are A, B, and C. So it makes the life simple for if we want to apply any algorithm, or you can say if we want to search how many students are having A grades, how many students are having B grades, and how many students are having C grades. Fine. So this is the way we are doing the integration, right? So what we have done here, that is, the data was there in different form. We have normalized them, right? So many things we have to do, and what are they? We have to do the data cleaning. You can say, why do we need to have the data cleaning? You can say that if the data is not proper, we may have to do the cleaning, right? Data is dirty, data is noisy, then we have to remove that. Remove that? No, we have to clean that. We find dirtiness inside that and we remove that. What are the ways that we will see for that particular topic? We transform the data. If the data is there, say for distance, if we have the data in meters, and for other data, if we have it in kilometers, then how can we apply any particular algorithm on that? We have to convert it in the same form. So maybe say kilometers are converted to meters, or meters are converted to kilometers, right? It is the simple example, right? When we are integrating, we have to take care of the normalization. That is, the data should be there in the same format, right? And multidimensional data model. So while we do the integration, we have to consider all these things. Data cube technology, what is that? That is, we can say, scalable methods for computing multi-dimensional aggregate. Multi-dimensional data, not only one dimensional. Multi-dimensional data is there, and in that we are taking aggregates. For example, we are taking the sum, we are taking the average, or you can say you are finding minimum or maximum or anything like that. Okay. For that, we can be using online analytical processing, and that is called OLAP. Multidimensional concept description, and for that we can be learning the characterization and discrimination. Data characterization, by summarizing the data of the class under study in the general terms. This will study in detail. Generalizing, generally, what is there, right? Or you can say that we can have the terms like generalization and summarization. Okay, we can consider a general. Say, for example, we are having, say, city. Say city, you can say Surat, you can say Ahmedabad, right? You can say Rajkot, right? You can say any other city. If you generalize that, then you can go to one level above. That is, you can say you will consider state, right? So that is general term for the cities, and that will be, say, Gujarat, right? Generalization. If, say, Gujarat, in the data whatever is given, if we are having the Gujarat, and if we want to go in the detail of that, that is, if we want to do these specific things, then we are going in the detail, and that will be the cities. If we go in the detail, then we'll consider the areas, right? So, how we will consider the areas? It is street names or area names, right? Say, you can say Gordod, or you can say Parley Point, or say Magdalla, right? So, when we are going in the detail, that is the specification or specialization. And when we are going above in the concepts, that is what we are saying is generalization. Fine. That is what we have talked of here, that is generalization. Fine. Data discrimination, that means what? By comparison of the target class with one or a set of comparative classes. Contrasting, like dry versus wet region, right? So that is discrimination. Fine. You are trying to have the difference. What is the difference between this person and this person, this class and this class, right? So that is what is the data discrimination. Okay.